All right, next up we've got esters. So let's take a look at how we prepare them. Remember we talked about the properties of esters. They smell good. Esters are found in a lot of foods to make them, smell good, obviously, and perfumes and all that kind of different stuff. So to create an ester, there's multiple different ways. For one, you could take a carboxylic acid, add a base to it to deprotonate it. That makes it a good nucleophile. And then you just add a alkyl halide, which is obviously a good electrophile. And then you're going to go ahead and do an SN2 reaction to end up with an ester. Of course, this is an SN2 reaction, so we have those limitations. Remember, it works better for methyl and primary alkyl halides than it does for secondary, and tertiary is just not an option. The other way we can do it is through Fissure Esterification. So in this case, what we do is we have some sort of carboxylic acid. We add whatever alcohol we're interested in adding, and then an acid catalyst. And what we'll end up here is with an ester, where this R came from whatever alcohol we added. If you think about the byproduct here, it's going to be water. And so this reaction is constantly in equilibrium. And then, of course, we can use Le Chatelier's principle to force the reaction to whatever side we want. In this case, if you want the ester, what you want to do is increase the concentration of the alcohol and then decrease the concentration of the water, right? So if your alcohol has a higher boiling point, you can just boil off the water. The other way to do it is to start off with kind of our king molecule, our acid chloride, which can basically turn into anything, and then just add some alcohol. Generally, you add some pyridine just to soak up any acid that might remain and not allow it to react further. And again, the R group here comes from the alcohol.